Numbers 10 through 13 on the Unit 3 practice test is one of these where it gives us a graph for the derivative and then asks us questions about the function itself. So number 10 wants to know, where is f decreasing? Decreasing means that derivative is negative. So I need the derivative of f to be negative. This is a graph of the derivative. So I want this graph to be negative. This graph is negative under the x-axis on the intervals from 0 to 2. Notice it's under the x-axis from 0 to 2. Now it's above the x-axis, and it's also under the x-axis from 4 to 6. Explain your answer. We did right here. We said that the derivative was negative. That's what we're looking for. You don't have to write it out in a ton of words. Just explain what you're looking for on that graph. Number 11 wants to know, where is f concave down? Concave down means that the second derivative is negative. The second derivative would be the first derivative of this graph. So it would be the slope of this graph. I need the slope of this graph to be negative, which is from 0 until 1. Now the slope's positive. The slope's negative from 0 until 5, but it's not negative at 4 because we have that sharp curve at 4. So technically you would want to split this up and say from 3 to 4 and from 4 to 5. Remember, we're looking where the slope is negative, and the slope is undefined at 4. The slope is undefined at 5, and then the slope is positive. Number 12, where do we have local extrema? Is each one a max or a min? So extrema occur when the derivative changes sign. I need f prime of x to change sign. This is a graph of f prime of x. So I want this graph to change sign. So the graph is negative until right here, and then the graph is positive. So the derivative changed from negative, so my function was going down until 2, and now my function's going up. That is a minimum. My graph is positive until 4, when it changes to negative. And my graph changes from negative to positive at 6. Negative to positive, so that's a minimum. For how you can tell, I would state that minima occur when f prime of x changes from negative to positive. Whoa. And maximum values occur when the derivative changes from positive to negative. And then finally, number 13 wants to know where we have a point of inflection. Points of inflection occur when the second derivative changes sign. So second derivative, remember, is the first derivative of this graph. Derivative of the graph would be the slope of the graph. I need the slope of the graph to change sign. So the slope of the graph is negative, and now it's positive. It changed sign at 1. The slope of the graph is positive, and now negative. Change sign at 3. Slope is negative, undefined, but still negative. did not change at 4. Slope of the graph is negative, undefined, now positive. The slope changed also at 5. So we are looking for where the second derivative changes sign, which would be the slope of that graph. It changes sign at 1, 3, and 5.